Okay, hello everyone. I'm going to continue what we have started yesterday. We have started the 3T application and also we have made it highly available. I'm going to continue what Joy has started. Let me share my screen. Okay. First of all, I will give you a recap what we have done yesterday. So 3T application. 3T application means you have front end, back end, and the database. So in here, we have deployed those applications separately. So front end in one EC2 and the back end in one EC2 and also RDS instance for the database. And also deploying them separately is not enough. We also need to create in the connection between them. So for that, we have created security groups and also did some configurations. Okay, let me go to the document here. I think this is the place she has stopped yesterday. Okay. Okay. First of all, I have said we have 3 separate instances to create this 3D application. And the next thing is we need to make it highly available. So to make something highly available, instead of having a single point of failure, we use redundant resources across different availability sources. So that's why she created yesterday couple of private subnets, couple of public subnets, and also she made the compute layer highly available, and also the database layer. Let's recap how she did it. Okay, let me make this zoom. Okay, here you can see high availability means designing the application so that it does not depend in only one resource. So instead of having a single point of failure, if we have, let's say, if we have only one EC2 instance and we have deployed application on that. So if that application, for XYZ reason, if that instance failed, our application can be failed. So instead of having a single point of failure, we use redundant resources. As I have explained here, we use redundant resources across different availability zones. So if any single resource fails, another resource is available. So application can continue running. And also, first of all, let's make our network layer highly available. So instead of creating only one subnet for each tier, we have our front end, back end, and also our database. That means web tier, app tier, and our database tier. So in web tier, we have created 2 public subnets instead of creating one public subnet. So we make it highly available. And also in application tier, we have created our application EC2 instance, backend database instance in a private subnets. So instead of creating one private subnet, we have created 2 private subnet for network layer high availability. And also, let's take the database tier. For that, we have created two private subnets, private subnet A and private subnet B. So the networking layer is highly available now. Okay, then let's go to the compute layer. So in compute layer, instead of running only one EC2 instance, we can run multiple EC2 instances across different availability zones. So instead of creating one EC2 instance, we have created two. We can create two for front end and also for the back end. And then the database layer. To make the database layer highly available, we have created, we have not created, we can configure multi-AC. But if you are in your free tier, you cannot configure it. But if you are not in your free tier, this option is available, multi-AC. So in multi-AC, you can have primary RDS and also there is a standby RDS in another availability zone as well. There are some couple of options there. Okay, let me log into my AWS console. Okay, I think Joy's document also have that one. Create in database. You can see a screenshot. Let me scroll up. You can find it. Okay, here. Yeah, I think the screenshot is not available here. Okay, no problem. What I was saying, if you are using multi-AC, we can have standby RDS in another availability zone. So we are actively using our primary RDS and there is a standby RDS in case if there any failure of this primary RDS. And it is saying the primary database handles the normal database traffic. The standby database is maintained in another availability zone for high availability. If the primary database becomes unavailable, standby becomes the new primary. It is saying RDS automatically performs failover. So the standby is not normally used to serve application read traffic. It means the purpose is high availability and automatic failover. And also here it is saying high availability across the architecture. For networking, we have created multiple subnets across ACs and also for compute, multiple EC2 instances across ACs and also database, multi-AC, primary plus standby. But keep in mind, if you are using free tier, this multi-AC is not available. Okay. The next thing is let's go to the document. RDS. Okay. Okay. Step 5 is, I'm going to start with this step 5 where she has stopped yesterday. So first of all, we need to install MySQL client in our backend instance. So for that, first of all, before we are going to do anything, we need to update the packages, and also we can upgrade the packages as well. So for that, we are running sudo apt update, and then we are running this command to install MySQL client. So using this MySQL client, we can connect with the database. From our backend instance, we can connect with the database using this MySQL client. So for that, we are running this command, sudo apt install MySQL client -y. -y we are using for auto approve. And then we can connect directly to this RDS instance. For that, we can use this command. MySQL -h. -h means we can add here our RDS endpoint here, this one. And then this is the port 3306, and this is the master username we have configured yesterday when we are creating the RDS instance. And also when we run this one and when we hit enter, it is prompting us to add our password. So it is also saying enter your master password when prompted. So after entering your master password, you are hitting enter, and then you are inside your MySQL like this here. Here it is said. You can see the command, and here you can see the prompt, enter password. You can add your password here, master password here. And then you can see she has run a command to view all the databases available. You can see we can run show databases command and semicolon. Here you can see available databases. And also, okay, let's skip this one. And then here, step 2, view existing databases. We have done this one. You can see the existing databases by running this command. And after that, you can create the database for this application. To create a database in MySQL, you can run this one, create database, and then we can add the name, then a semicolon. And we can verify. After we are running a command, we need to verify what we have done. So for that, we can run this one, show databases. And then we can verify. You can see here. First, we have creating the database, and then we are verifying the database is created. You can see here, book review DB is here. And then we are going to create the environment variables file. So the backend application uses a .tne file. Okay, let me go to my, okay, here. You can see here. Our backend need to communicate with the database. The backend cannot connect to RDS unless it knows where the database is and how to authenticate to it. So we provide the required database connection details through the backend.tnv file. So for an example, here I have added an example. First of all, we need to give DB host. DB host means we can add the RDS endpoint here, and then DB port. It is 3306. and then the database name. We have created it here. The database name, book review DB here. Okay. Here, as the steps, she has, first of all, she has navigated to the backend directory because we are configuring the backend, and then this is the command, and then she has created the .env file by using the touch command, and then she has verified the file has created. We can verify before we are doing anything. So for that, she has run ls-la. You can see the .tnf file is here, and we are inside the backend. And after that, she is mentioning generating a JWT secret. So JWT means JSON Web Token. So generate a secure JWT secret with OpenSSL on your local machine or EC2 instance. This is the command. So let me go to mine. Okay, here. Let me scroll up. Okay. JSON Web Token in the backend.tna file. Our application has user authentication. So after deploying our application, we need to do the user authentication. So after registering, user is trying to log in. When user is trying to log in, he is giving his email address and password. And when a user logging, the backend first checks whether the login credentials are correct. That is the first thing. So after that, backend verified those credentials, and after that it is login the user. And after successful authentication, the backend creates a JWT token, JSON Web Token, for that authenticated user. So here, using this this command, we are creating a random secret. I will explain you the command. And for that, actually in our .tna file, we are adding the JWT secret. So in this step, we are creating that one. And here you can see, why do we need a JWT token? Okay. After the user logs in successfully, we do not want them to send their username and password again with every API request. So you can see the flow. User is logged in, and then backend authenticator that user, and backend creates and signs JSON Web Token, and then that JSON Web Token is returned to the client. Later, when the user sent a protected API request, let's see, through the front end, user is sending an API request. Then that API request and JSON Web Token are coming to the backend, and then backend verifies that JSON Web Token, and then it is verifying the user as an authenticated user, and then that request can continue. Backend is running the logic according to that API call. So we can think of JWT as proof that the user has already been authenticated. Okay. And after that, why do we use OpenSSL? We also need to know why do we need OpenSSL. So we need the JWT secret to be strong, unpredictable value because this is a secret value. So in this project, we generate it using this command, this one. So this is telling, oops, sorry, this is telling create a random value. And also here OpenSSL is simply being used as a security tool to generate a strong random value. So we are doing that using this command. This is the length of the secret. Okay. And then, okay. And also, if your machine have not installed OpenSSL, first of all, we need to install that. So for that, as we done previously, we need to update our packages, and then we can install OpenSSH like this. And then add backend database configuration files in .tnv. So we are opening the .tnv file we have created earlier using nano. And then you can see the configuration. You can see the backend port here. And then you can see the database details and credentials. You can see DB host as database endpoint. And then DB port is 3306. And then DB name, we have created this earlier using MySQL client. And then our master username was admin. We add in that here. And you can add the password you have created as the master password. And then this DB dialect is MySQL because we selected MySQL. And then JWT authentication. Here you can add the JWT secret created by the here. OpenSSL. We have created using OpenSSL. And then here we have added course. Course means cross origin resource. I cannot remember the full name. 1 minute. Okay. Cross origin resource sharing. Okay. CORS means it's a browser security mechanism that controls which front-end origin are allowed to make requests to a back-end API. So in our front-end browser, it is making API request to backend. And what backend is doing is it is checking CORS. Is this front-end origin allowed? From where it is verifying. For that, we are adding it here, allowed origins. You can see the load balancer here, DNS here. And also we have added this local host with the front-end port as well. Okay. Here it is saying, is this front-end origin allowed? If yes, allow the browser to use the response. If no, browser blocks the access to the response. Okay. Allowed origin part is done. Okay. Then we need to verify the configuration saved correctly. For that, we can run cat command and view the content of this .tnv file in our backend. Okay. And also the value saved correctly using this grep command. Can see here, you can see the .tnv file. We can see the port and also database host. You can see the host name here and also DB port, DB name. We have created this and master username, master password here, and also the dialect as MySQL. Also JWT secret is here and allowed origins are here. Okay. You can see the explanation here as well. Okay. The .tnv file stores configuration values the backend application needs at runtime. Database connection details, the port to listen on, authentication secrets, and course. Rather than hard coding these values directly into the application source code, they are kept in a separate file that's read when the application starts. This is a standard practice. Okay, you can see we can keep the sensitive information separately because we don't need to hard code them in our source code. Also, it is making it easy to reconfigure the application to a different environment. Like we can have environment like dev, staging, pre-production and production without touching any code. Because if we are hard coding it, we need to go to our source code again and run it. So here you can also see JWS secret is a randomly generated string, as I already said. Okay. And also it is explaining about the allowed origins as well. Cross origin, resource sharing, and there is a explanation for that as well. You can go through it. Okay. Here we are starting the backend application. We are going to test it. So for that, first of all, we need to confirm we are in our backend folder. For that, we are running this and then we can confirm it using our pwd. And then we can run this command to start the backend. So we can expect an output like this because task configured. So you can see here. Yeah, I think it is visible. Here we have run, it is not clearly visible, not src/server.js. When we are running it, you can see it. Database, this one connected successfully with SSL and these things. Okay. We need to verify the backend is running. So for that, we need to open a new SSH session because if we are on Control-C and stop this, it is not again running. Because of that, we need to open a new SSH session and then we can curl it. Curl http://localhost. So we are going to curl this one and then you can see book review API is running. So it is working. Okay. Here we have added an explanation as well. You can go through it. You can see when the server started, perform several things in sequence visible in the expected output. Loads environment variables, establishes secure SSL connection, synchronize the database schema, sees the database with sample users, sample books, and also sample reviews. That's why you can, when you are deploying this app, you can already see some sample books, users, and reviews. And also it begins listening for incoming request on port 3001. So backend is listening on this port. Okay. Also, we are going to, in this way, using here, you can see node src/server.sh. Like this, we are running our application in foreground. So that's why we need to open a new SSH session. So instead of that, we can use PM2. It will be explained after doing this, and then register the application EC2 with the target group. Okay. So for this load balancer, we have a target group. So to register the application EC2 with the target groups, we need to first go to the EC2 console, and we can then go to target group. And then you can see here. You can see the available instances here. Okay, let's go to the steps again. I will explain it. First of all, you need to go to the EC2 console and then to the target groups. And then you need to select book review app target group. And then we need to open the targets tab. And then you need to register targets. For that, you need to click on register targets. So then we can add our app EC2 there. So here you can see EC2, then target groups, and then we are selecting book review web target group and then register targets. And then from available instances, we are selecting book review app EC2. And then this is the last step. Register pending targets. You can click here. Also, you can see here ports for the selected instances. It is 3001 because backend is running on port 3001. And after that, you can see one target registered successfully to the book review web target group. You can see here one total targets and it is also healthy. Okay, you can see the explanation here as well. The application target group contains the backend EC2 instances. So in our application tier, we have our backend EC2 instances that the internal application load balancer can send traffic to. Registering book review app EC2 connects the actual backend server to the target group. So we need to, okay, let me say it like this. If you are creating a load balancer, we need to create a target group. So inside that target group, we need to register targets. They can be EC2 instances and also they can be some other things like what do you call that? Containers like that. So in this case, we are using EC2 instances. So here for our internal load balancer, there we have our backend instances. So to connect them with our load balancer, we need to register them. That's what we have done here. And also it is saying internal load balancer regularly check the backend health on port 3001 using the configured health check path. We have already configured the health check path when we are creating load balancers. Okay. When the instance responds successfully, it is marked healthy, and the ALB can begin forwarding application traffic to it. ALB only forwarding application traffic to it if it is healthy. Okay, you can see here it is also saying a healthy status confirms that the ALB can successfully communicate with the backend EC2 instance. If the target is unhealthy, the backend may not be running, or the book review app security group may be blocking traffic on port 3001. Okay, here you can see run the backend with PM24 persistence. Okay guys, give me 1 minute. Give me 1 minute, I will drink some water and come back. Okay, I'm back. Okay, so run the backend with PM24 persistence. Earlier, the backend was started directly with node src/server.sh. So before we need to run our backend, and then we run this command. And then when we need to test our backend, we need to create a separate SSL session. The reason is running in foreground. So because if we run Control C and stop that, we cannot test it. So you can see here, while this confirms the application worked, running it this way ties the process to the terminal session. The moment SSH connection closes or timeout, the backend process is killed, taking down the entire application, since the front end depends on it for all data. So in this treaty application, front end is sending API request to the backend. So after that, backend is querying data from the database, and then it is the queried data coming back to the backend, and then it is providing to the front end again. So to run the backend reliably in production. So in production, we cannot use a method like this. So for that, to run the backend reliably in production, it need to be management by a process manager. So that keep it alive independently of any single terminal session. Restart it automatically if it crashes, and bring it up back automatically if the EC2 instance reboot. This is exactly what PM2 provided. PM2 need to be installed once system-wise, so it's available as a command line tool regardless of which directory you are in. So we need to install it, and also when we are installing it, we need to do it system-wide. So if you are doing like this, it will be available as a command line tool regardless of which directory you are in. Okay, you can see here. To install PM2 globally, we need to run this command. Sudo npm install -g PM2. -g means globally. And then after installing it, we need to verify our installation. For that, we are running PM2 -- version. And then we need to start the backend under PM2. So first of all, we are navigating to our backend folder like this. And then we need to confirm we are in our backend folder. For that, we are running pwd and confirm it is backend. And then you can see here, we are going to start the backend under PM2. For that, we are running PM2 start, and then this is the command, and we are giving here name as backend. Okay, you can see here the output after running it. Okay, you can see the explanation here. This launches the Express server the same way node src/server.js did. So it is doing the same thing as we run this one to start our backend, but hands control of the process over to PM2. So, and you can see here the //name backend. That flag labels the process for easy reference in later PM2 commands. So, this is like a flag. It is like a label. So we can easily reference this as backend. From this point on, src/server.js should always be started this way. Never run directly with node again to avoid two processes competing for port 3001. And you can see here, the single PM2 start command both launches the process and put it under PM2's management. It replaces the need to ever run node src/server.js directly again. It is saying we don't need to run this command again. And you can see the output from here. Okay. The next part is, let me close this one. Verify the backend is actually serving request correctly. So for that, we can curl this one, curl -i. We are running this in localhost, and we can see if this is actually serving the request correctly. Okay, here you can see it is curling the localhost on port 3001. And you can see here book review app is run. Okay, this command is not added. Let's see. Okay. Okay, no problem. Okay, I think it is mistakenly added. Okay. Okay. So we need to save the PM2 process list. To that, we can run this command. Just run PM2 save. Then you can see saving current process list and successfully saved in here, this one, this folder. And then register PM2 with systemd to survive reboots. Okay, let's go to the explanation. Okay, you need to understand the PM2 before you configure it. And also this, you can do the assignment without PM2 as well, but this is the best practice. Okay, what is PM2? It is explaining what is PM2 here. PM2 means the word is Process Manager 2. That means PM2 is a production grade process manager for Node.js application. In simple terms, it's a tool that runs your Node.js application in the background. So if we are just running our command in foreground to start our application, we need to start the separate sessions to do testings and other things. So instead of running in foreground, it is saying runs your Node.js application in the background, keeps track of it, and it is taking the responsibility to keeping it alive. So you don't have to babysit it in an open terminal window. Without PM2, running a Node.js app usually means type in something like node src/server.sh directly into a terminal. This works. Actually, it works. We have run that command and also we have tested. It was working. This works. But that's not the issue. But it comes with a serious limitation. The application is now tied to that exact terminal session because we have started our backend there. So our application, it is now tied to that exact terminal session. So if you accidentally close that terminal, or if you lost your SSH connection, or your laptop goes to sleep, or if the process dies immediately, our application will not working. So, and we have explained why this matters for this project. So here we have explained the backend application on the app EC2 instance need to be available at all times because we are sending API request from our front end to our backend. So our so from that backend application, we are sending queries according to those requests. So our backend application, it need to be available all the times. So real users interacting with the front end depend on this backend being reachable every time they load the page, register an account, or submit a review. So after you deploying the app, you can you need to register yourself. After registering yourself, you need to log in, and also you can see the reviews. See the reviews. If you can remember, there are already some sample reviews are creating when you are deploying the application. You can see those reviews, and also you can log in and add your review. Without registering, you cannot add the submit a review. So if the process dies the moment an administrator disconnect, the entire application effectively goes down with them. This is exactly the situation encountered earlier in this project. So we have deployed our application and we have started in one SSH terminal session our application. And then in case if we have closed it, the whole application is not working. So this is exactly the situation encountered earlier in this project. The backend was started with this command for an initial test. The SSH session was later closed and the backend process was killed as a direct result, even though nothing was actually wrong with the code or the database connection. PM2 exists specifically to prevent this class of problem. So actually PM2 is preventing this thing. It is running the application in our background. Okay, here you can see what is PM2 actually does. PM2 provides four core capabilities that matters for this deployment. Okay, you can see as the first one, it is keeping our process running independently of any terminal session. Once a process is started under the PM2, it continues running in the background as a daemon. It is completely detached from the SSH session that launches it. Okay, as I said earlier, it is running in the background as a daemon. And also, it automatically restarts the process if it is crashes. If the Node.js application throws an unhandled error and exists unexpectedly, PM2 detects this. Okay. As it is explained here, if the Node.js application throws an unhandled error and it can exist unexpectedly. So PM2 detects this and it is restarting it immediately. And also it is not requiring a manual intervention. That's the main thing. And it is restoring the application automatically after a server reboot. Okay. On its own, PM2 only manages processes for as long as its own daemon is running. A full instance reboot would normally wipe out that too by registering PM2 with systemd. Systemd means Ubuntu's service manager. PM2 itself gets started automatically at the boot and it then restruct whichever processes were saved beforehand. Okay, it is saying after a server reboot, it is restoring our application automatically. And also, it is giving the visibility and control over running processes. You can run the commands like PM2 status and you can see what is running, and you can run PM2 logs and you can see the real-time outputs, and also you can run PM2 restart commands like that. Also, you can see overall process at a high level. That means setting up PM2 for the backend follows a consistent pattern that will be repeated again for the front end in step 5. Install PM2 globally on the instance. So it is available as a command line tool. That's why when we are running commands, we are adding this PM2 because it's a command line tool. And then start the application under PM2's management, replacing the earlier manual node command. We have run this command as well. And after that, verify the application is actually serving traffic correctly under PM2, not just showing as running. And also save the current process list. So PM2 knows what should be restored later. So to tell it what should be restored later, we need to save the current process list as it was this command was explained earlier and we ran earlier. And also register PM2 with systemd. So the operating system itself brings PM2 and it saved processes. And also, as I explained earlier, the 4 core processors, it is okay here. Backup automatically after any reboot because we have registered PM2 with systemd. And then save once more to make sure the process list reflects everything, including the new startup configuration. Each of these steps is convert individually below with the exact commands and expected output for this project. Okay, the next thing is we have done with the backend and we are going to the front end now. We are going to configure the front end. You can see what we are going to do. Update the server, install Git, Node.js and Nginx. Okay. Our goal is configure the web EC2 instance to build and serve the Next.js frontend. As explained in the README, the frontend is Next.js and also we need to install dependencies. For that, we have a specific command. And then connect in the backend through Nginx and the internal ALB. And then getting the application ready to receive traffic from the public ALB. Let's see how to configure it. Okay. First of all, we need to connect to the EC2 instance. These are the commands we need to run. As here, we are giving the permission for our key and then we are running this command to connect with our instance. And then you are inside your web EC2 instance and then you can update the server and install Git. So for that you can run sudo apt update and also you can run sudo apt upgrade -y as well. You can update and update and upgrade your packages. And after that you can install Git. Then you can check if the Git is installed using this command git -- version. If the Git is installed successfully, you can see the Git version here. And okay, you can see here we are installing Git and then we are checking the version here. You can see 2.53.0. And then we are installing the Node.js. For that, we are using this command. And after that, we need to run these 2 commands to install Node.js. And after that, we can verify it using node-v and npm-v. And then we need to install Nginx using this command as usual. And after that, as usual, we need to enable Nginx, start Nginx, and we need to check the status using these commands. Okay, you can see here the commands has ran. And then we need to clone the front end repository. Okay, actually the repository is same. We are, as you can see here, we are cloning this same repository and we need to navigate to this front end. Okay, I think this repository need to be changed. This is a fork, and then we need to navigate to our front end. For that, we need to run this command, and then we can confirm we are in our front end folder. For that, we are running pwd, and then also we can run ls to see what is inside. So if you go here, you can see the output. This content will appear on the command line. Okay, then you can view package.json to understand the project script and dependencies. Okay, for that we need to run cat package.json. Okay, let's go inside package.json. As you can see here, we can see the dependencies inside this package.json. Okay, you can see here dependencies and versions are added here. So when we are running, also here you can see it as well. We have added dependencies with versions. Okay. Here you can see the app is cloned, and then navigate to this book review app, and then run ls, and then you can see the backend and front end and other things, and then navigate to front end and run ls. Then you can see the content inside here. Okay, and it is explaining it is used to clone the project source code onto the web EC2 instance. You know about that. And then Nginx is installed specifically for the web tier because we need to create a reverse proxy. Otherwise, when we need to add the port as well. So instead of that, we are creating it as a reverse proxy. And here sudo systemctl enable Nginx ensures Nginx starts automatically when the EC2 instance reboot. You know those things. And also after that, we are configuring environment variables. Okay, I think npm install is not here. Okay, let's take it later. So when we are running npm install, these dependencies are installing. So we have reviewed this package.json file. So later when we are running npm install, these dependencies with their versions will install. Okay. This explanation are done, and then configure environment variable. The front end needs to know where to send API requests. So when a user interact with the front end is, let's say user need to see a review. For that, user is clicking, or user need to add a review. So for that, user need to send a API request to the front end need to send a API request to the backend. So for that, front end need to know where to send API request. That is the internal application load balancer, not the app EC2 directly. traffic must flow through the application load balancer, so it's load balanced and the backend is stayed private. Okay. Okay. As I said earlier, we have load balancer and we have created target groups and we registered our targets there, our EC2 instances there. So when we are sending API requests, they are not coming directly to the app EC2s. Instead, they are coming to the internal ALB. That is what I explained here. And then these are the commands we are going to run. So first of all, we need to confirm we are in the front end. For that, we are navigating the front end using this command, and then we are creating our e.tne file in front end. And you can see we are adding this line in our file. This one. Okay. Sorry. Here you can see an explanation. The front end needs to know where to send its API request, but it should not use the internal ALB's DNS name directly. The reason is the internal ALB is only accessible within the VPC. So a user in a browser, they are in the public internet, they cannot reach it. So instead, next public API URL is set to /API. This creates a same origin request, meaning the browser sends API request to the same web EC2 server that is serving the front end. For example, a request such as /API /users/register. So this request means we are going to one user need to register. So he's giving his name, email address, and then a password, then trying to register. First reaches Nginx on the web EC2 instance. And Nginx then acts as the middle layer that forward this /API request to the internal application load balancer. So, which send them to the backend EC2 instance. Okay, let me explain it from here. Okay. This one was done. Okay, here. Okay, you can see the purpose of this to tell the front end when you make an API request, use /API as the starting path. For example, if the user want to see the reviews for book 5, that is the book ID, the front end can send a request like this. The reason we use /API instead of putting the internal ALB, as I explained earlier, here the internal ALB is private. The user's browser is outside our VPC. So the browser cannot directly read the internal ALB. Instead, the browser sends the request back to the same web application using /API. You can see here the flow. User clicks something in the browser, front end sends /API request, and then request it to the web tier, and Nginx checks the path. Nginx has a rule for request starting with /API. If you are going to Nginx config, you can see it here. Okay, you can see location/API. Then it is considering it as a API request and navigate it here. Load balancer. And then here you can see when Nginx sees that prefix, it knows that the request need to go to the backend. Nginx then forwards the request to the internal ALB. And the internal ALB forward it to the backend EC2 because it is in the target group. Here you can see location/API proxy path to here. Load balancer, internal load balancer. Browser API request, and then it is going to public ALB, and then it is coming to this Nginx, and then to the internal ALB, and then to the backend. Then backend is running the logic. Okay, that part is done. Okay, our next one is configure Nginx as a reverse proxy. Okay, first of all, we are checking the status of our Nginx, and then you can see this is where Nginx configuration file is /etc/nginx sites available /book preview. This file is what we are creating, this one. So this is the path. So if you are running ls here, sudo nano, sorry, not nano, you can run ls and this one. Okay, let me go to my document. I can explain well. So sites available. Okay. Okay. In this sites available, you can see /etc/nginx sites available. This is like the not site available. Yes, sites available. This is like the place we are keeping our draft. Like here you can see /etc/nginx sites available. Configurations you have created and you want to keep them. You can keep them as draft in this folder. And then in this sites enabled, we have another folder called sites enabled. And there, those are the configurations Nginx actually using. So what we are doing is, first we are creating our configuration file here in sites available. Then we are adding symbolic link to this sites enabled. So here you can see you can keep a config file in sites available, and when you want to enable it, create a symbolic link to sites enabled. As an example, you can see this command. We are going to run this. You can see in the document. If later you want to disable that site but keep the config file for future use, you can remove only that symlink, that means symbolic link. You can do it like this: sudo rm/etc nginx sites enabled /book preview. So if you remove this symbolic link is removed, but this file is available in sites available. That is what it is saying. the original file list, sites available stays there. Okay, you can see we check the Nginx status and then we open this one. We created and open this file. Also, you can edit the default file as well, but if you are creating one, that's easy and better. And you can copy and paste this file, replace with your app ALB endpoint. Okay, this is the configuration. Here, when you're doing it, you can copy and paste and you can change this with your ALB. I will explain it. Okay. Here in this documentation, it is mentioning enable the site. This step is easy to miss, and skipping it means Nginx will keep serving its default page instead of this configuration. Because as I explained earlier, if you are keeping this only in sites available, it is not a configuration Nginx actually using. So we need to add it to this sites enable. So that's how we enable it. And then here what we have done. So currently we have our default in our sites enable. So we need to remove that symbolic link. So for that we are running this command and remove the symbolic link from this default file. So this one will be available in sites enable folder. This default file will keep as a draft in this sites available. Okay. You can also confirm this symbolic link is correct. For that, you can run this command ls-l and you can check if this is available there. Let's see if the command has run so I can show you and explain.
Sorry, Janet, what did you say about the defaults? Can you go back and repeat what you said about the defaults?
Sorry?
The default enabled, was it the site available / defaults?
Okay, I will here.
Yeah.
This one.
Yes, what did you say about it? Yes, please repeat what you said about it.
So when we are initially installed Nginx, you can see a home page. When we are going to our browser and run http:// and then our public IP. Then you can see some default page. For that, we have a default configuration. So that one is initially having in this sites enabled. So what we have done is, first of all, we have created this one here. Sudo nano, we have created this one, this configuration file. We named it as book review. And then we have created it in sites available. But we need to create a symbolic link to this sites enabled. So using this command, we did this. But if you run ls in this sites enabled, still we can have this default file as well in that folder. So if we didn't run this one and if we go ahead, it may be a conflict. So to avoid that thing, what we are doing, we are removing the symbolic link using this command.
Yeah, thank you. It's clicking. Thank you.
And if you we are removing this, and then we run this one in sites enable, we can see the file we have created. So there will be no conflict with this default. So the original default file, it is available in this sites available. We are just removing the symbolic link here. Okay. After that, we can check the Nginx configuration using this sudo nginx-t as we are usually doing. And then we can restart Nginx to take these changes. Okay. Okay, and I need to explain this Nginx. Okay. I will go to my document. Okay. Nginx is installed on the web EC2 instance. We have done it. And its job is to receive incoming request and decide whether they should go to the front-end application or the back-end API. So as I explained earlier, it's listening on port 80. And then you can see here location/API. As I explained earlier, it is coming to app ALB. And then if it is not coming with this as an API request, it is just going to our front end. Okay. I have a chart. Give me 1 minute. Okay, starting with. Okay. You can see here. Listen 80. Nginx listens for incoming HTTP request on port 80. So that's why we are creating this reverse proxy. And incoming HTTP request is coming to web EC2 port 80 and coming to Nginx. So request starting with /API, as you can see here. If the request starts with /API, Nginx identify it as an API request and forward it to the internal ALB. For example, like this. See the reviews and user login like that /API. From the browser, it is coming as an API call and it is going to Nginx, and then because it is like this API call, it is going to internal ALB, and then it is going to the backend, and backend run that logic, application logic. Everything else goes to the front end. So you can see location as /. And then you can see proxy pass localhost. That means we are in our front end application. So localhost means that EC2 server and port 3000, because our front end is running on port 3000. The next JS front end application is running on port 3000 on the same web EC2 instance. So requests such as this do not start with /API. So Nginx forward them to here, localhost 3000. Okay. Here you can see how Nginx route those requests. Request is coming to Nginx, and if it is start with /API, it is going to internal ALB and going to the backend. Everything else is going to come into this next.js. That means front end. So Nginx is acting as a reverse proxy. It receives the request first and forward it to the correct application based on the URL path. Let's see the explanation here. Okay. A reverse proxy is a server that sits in front of one or more backend application and forward client requests to them on the application's behalf. Here, Nginx runs on the web EC2 and handles two jobs at once. It serves the Next.js frontend for regular page requests. So, it is also serving the regular page requests. You have seen it is if it is coming to slash here. Okay. If it is coming to slash, it is pass into localhost 3000. Okay. This part is done. It serves the Next.js frontend for regular page requests and it forward anything under slash API onto the internal ALB, which then route it to the back end. I have explained it. And each directive plays a specific role. Listen 80 means accepts incoming connections on the standard HTTP port, which is what the public ALB forwards traffic to. And location API, I have explained earlier, matches any request path starting with slash API and forward it to the internal ALB rather than to the local frontend. And then location slash. That matches everything else, the actual application pages, and forward it to the Next.js process running locally on port 3000 localhost colon 3000. Okay. Proxy pass. This is deliberate. A trailing slash here would cause Nginx to strip the slash API prefix before forwarding the request, sending the backend a mismatched path, e.g. slash books instead of slash API books. That wouldn't match any real route. Leaving it off preserves the full original path. And you can go through these things. I have covered the important things here. And here, this part is important. Without Nginx acting as a reverse proxy, the browser would either need to know two separate addresses, one for pages and one for the API, or the internal ALB would need to be made public, directly undoing the private design established back in phase 4. But having Nginx sit at the edge and route based on path, the browser only ever needs to know one address. So we are providing one address, while the backend and database stay fully private. So in our current architecture, our backend is private and also our database is also private. This completes the intended request path for the architecture. So user is coming to WebEC2, that means Nginx, and then it is going to internal ALB and then application EC2 running on port 3001 and then going to database RDS MySQL. And also I have, as I have explained earlier, enable the site matters because Nginx by default only serves configurations that are symlinks into sites enabled. By default, Nginx only serves the configurations that are symlinks into sites available. Enable. A file existing in sites available alone has no effect. Skipping this step result in Nginx silently continuing serve the default landing page. Continuing to serve the default landing page, even though the correct configuration file exists and is syntactically valid. Okay, you can see here we have run sudo nginx -t, and also we have run reload the nginx. And then we are going to install front-end dependencies. Okay, you can see first of all we need to navigate to our front end, and then running pwd we need to confirm it, and then we need to run npm install. So as I explained you earlier, here front end we have package.json. We are installing these dependencies by running this command npm install. And after installing those things, you can see here. Okay, this only has the build step. Let's see. Oh, okay, you can see here. You can see here node modules. So after we run in this npm install, it is we are having a new file called node modules. So all the dependencies are inside here. You can see it is very long list. Okay. After that, we need to build our application. To build our application, we are running npm run build. Okay, you can see here we have run npm run build. And you can see here our application is building. And after that, she has run the ls node modules. This one. Okay, build file. Okay, let's. Maybe the screenshot is there. No, it is not. Okay, no problem. Installing dependencies. The front end depends on several packages defined in package.json, Next.js itself, React, and any supporting libraries. npm install reads that file and downloads every listed dependency. You can see there are so many things here, along with their own sub-dependencies. You can see along with their own sub-dependencies into node modules. Node modules is what we have ls here. So dependencies along with their sub-dependencies as well. And then this step is required before anything else can run. Since command likes next build and next start rely on the next binary actually being present on disk. Without it, those commands fail immediately with an error like next not found. So checking ls node modules afterward is a quick sanity check, that is that the install actually completed. So after we running npm install, as a habit we need to run this ls or ls node modules. So we can confirm this command has successfully run. Okay. And you can also see here an empty or missing node modules folder is the most common cause of confusing failures 2 steps later. So it's worth confirming here rather than assuming. So when you're developing something, when you're deploying something, don't assume things. Instead, you can check it because it is taking around 5 to 10 seconds and it will save a lot more time for uh, if you need to debug later because these things are missing. Build in the front end. npm run build runs the build script defined in package.json, which called next build internal. Okay, in here you can see here scripts in this package.json. Okay, which calls next build internally. You can see here. Okay, this compiles the application into an optimized production-ready set of static files and server bundles. A meaningfully different process from Next.js development mode, which is slower and include extra tooling not meant for production. This step also compile and type checks the code, lint for errors, pre-renders static pages where possible, and marks dynamic routes to be server rendered on demand. Okay, and it is also saying generating optimized route specific JavaScript bundles, so the browser only downloads what a given page actually needs. Critically, this is also the points where nextjs.env.local and bakes next public API URL. If you can remember, we have added this in our .env.local as /API directly into the compiled client-side JavaScript. This means the environment file must be correctly in place before running the build. Any change made to .env.local afterward has no effect until the project is rebuilt. So this .env.local file must be configured, must be created before we are building our application. And also we are running our front-end app also with PM2 for persistence, as I explained earlier. Okay, as we did earlier, we are installing this PM2 globally, and we are checking. We need to verify if the PM2 is installed. For that, we are running PM2// version. And then we can start the front end under PM2. So for that, first of all, we are navigating the front end using this command. And then we need to start it. Start using this command. You can see. Okay. After we navigate into front end, we need to run pwd and confirm it. After that, we can run this command. And we can check the status. And we can verify it is serving locally. So for that, we can run curl-i http and localhost. We are going to verify it is serving locally. So we are running localhost 3000 because our application is running on port 3000. You can see the output here. This is showing as 200 OK. And also we are running this command to save the PM2 process list. And also we are registering PM2 with systemd as explained earlier. Okay. Save once more after enabling startup. We are saving once more again. And then checking status. And then can see here if you make any changes after PM2, now manages the app, rebuild with CD frontend. navigate to front end and you can run npm run build. That means we are rebuilding our application. And then we are restarting our front end again with PM2. And then we are save as we did earlier. And also we can confirm if it is enabled using this command. And you can see screenshot which has run it. You can see he has enabled. Also we can run this to Nginx as well. We have done it earlier. Okay. And you can see an explanation here why PM2 is using here. PM2 used here for exactly the same reason it was used in the backend. See that section for the full explanation of what PM2 and why it matters. In short, without PM2, npm start ties the front-end process to the terminal session that launches it. Meaning, it dies in the moment that SSH connection closes. PM2 keep this running immediately. If you remember, we have discussed 4 major things PM2 is doing and also why we need PM2 previously. And the same thing is summarized here. Okay, you can see. Meaning it dies the moment that SSH connection closes. PM2 keeps it running independently. Restart it automatically if it is crashing. And once registered with PM systemd, not PM2, it is systemd, brings it back up automatically after any instance reboot. The same install, start, verify, save, PM2 startup sequence apply here as it did for the backend. Okay, here as a final step, we are going to do full end-to-end testing. We are going to test the backend directly. Okay, for that, we are running this command, localhost 3001/API/books. And you can see the example here. You can see it is showing as 200. Okay, and you can see here. Let me zoom this. You can see we have this API call is for books. We can see book ID. Book ID as 1. Book title is the pragmatic programmer and the author is Andrew Hunt. And also you can see the rating for that book here as 4.8. And also you can see created that this date and this time, updated that this date at this time. And also let's see another book. Okay, this one. Okay, you can see here ID is 3, title is JavaScript, this one. Okay, and also author is Douglas Crockford, rating is 4.5. This is when it's created, when it's updated, you can see those things. So that test is done. We have tested the backend directly. It is doing in WebEC2 locally. So the command is this one, curl-i http://localhost 3000. Our front end is running on port 3000. You can see here 200 OK. And also the other things. If you run capital I here, you will get only the headers. Okay. Then we are going to test the full chain through Nginx WebEC2. We are doing this in WebEC2 locally. Here you can see curl -i http localhost/API/books. Okay, so here we are sending an API call for the, so you can see here it is, here you can see 200. Okay, and we send this for books, and as previously we can see, as we have seen previously in our backend, we can also see it here, book ID and the other details of this book and the ratings and all the things. Okay, now we are going to test it in a browser. So earlier we have tested all of these things in CLI. Okay, you need to navigate to http:// and your public IP. This public IP should be your WebEC2 IP, and confirm homepage loads and displays the book list. I think you have, okay, like this. You can see here, we are in this address bar, we are running http:// and this one, and then this will be, and you can see the books here with their authors and also the ratings. And if you go inside here, then you can see the reviews as well. And from here you can register. From here you can log in after register. Okay, these are the tests. Confirm homepage load and displays the book list. So you need to see an interface like this. And register new account successfully. You need to register. You can click here and it will ask you for your name, your email address and also password, and you can register. If you register successfully, here you can see your name is in this login. And if you need to log out, you can do it as well, and you can log in again as well. Okay, sorry, I think as I can remember, after registering you need to click login and then you need to log. After logging you can see your name here. And then open a book's detail page and confirm reviews display. That means you need to click one of these book, this one, or this one. And then you can see a detailed review of that book. Book name, the review, who has done the review, the author, the ratings. Rating is also displaying here. And then submit a review and confirm it appears. You can click in on any book here and you can select add a review, and you can add your review, give your rating, and then you can submit. Then it will appears. If you can do it successfully, this app is successfully deployed. You can confirm it. Test in a browser through the public LP. So previously we did it with this using the our WebEC2 instance public IP. So now we are going to use the public ALB. So you can navigate to a public ALB using your one, and then confirm homepage loads and displays the book list. This one is only changing, and you can do the same things you have done here if you are login. If you test the app using this one in the browser, it is asking the same things. Okay, you can see here it. You need to add your full name. This is a register page, register window. You can add your full name. First of all, you need to click here and you can add your full name, then the email, and you can add password. Here you don't need to add real one. You can add anything like example.com or something. And then you can click on register. After registering, you can see registration successful. Please log in. Then after that, you can log in from here. And then you can see we have gone inside this clean code book. We have gone inside there. Then you can see the author and the ratings, overall ratings, and then you can see previous review here. And here, from here, you can add a review. You can write your review here. Write your review here, give your rating, and submit your review. Then it will appear here. As you can see, these reviews appear here. So likewise, you can confirm your application is working. And then why we are doing this? Testing at each layer. Backend locally. First of all, we have tested it in backend locally, and after that we have tested it in frontend locally, and also in frontend we have tested it through Nginx. As I explained earlier, if the API request is coming as coming from frontend as slash, then it will come as /API. So it will go through Nginx, and then it will go to internal load balancer, and after that it will go to backend, and backend run the logic. So here you can see through the public IP. Also, we not only tested through the public load balancer. We have also tested it through the public IP of our web server as well. And finally, we have tested it through our public ALB. So this will isolate exactly where a failure would occur if something breaks. This layered approach was what made debugging possible through this project. So if you are following this approach, you can, if there are any error, you can debug easily. And when the full chain curl failed, but the backend's local curl succeeded, that immediately narrowed the problem down to Nginx or the internal ALB. So according to the failure, you can decide what happened. Or you can also get the help from AIs like ChatGPT or something, but don't directly at the whole code, the whole CLI commands you have run and ask for the solution from ChatGPT. Instead, first you need to think, you need to inspect, and after that you can narrow down the issue and you can ask from the ChatGPT or any other AI platform. Okay. The browser test is the final test and most important check. Since it exercises the application the way real user actually would, including client-side JavaScript execution, which is where several of the bugs in this project, the /API path doubling, only became visible. So you need to test to the browser. We have done it using our public IP and also using the public ALB as well. Okay, we have done the discussion. And then from these references, you can see application repository, and also these are some official documentation. And one thing I need to mention, if you are searching in the internet, the answers for your questions, always try to find resources from official website. If it is related to AWS, try to find the answer from AWS official page. If it is Azure, try to find the answer from Azure official page. And also, if it is related to any other thing, always try to find the answer from official pages, because it will give you the correct details. Here you can see some documentations, you can go through them. About net gateways, VPC route tables, internet gateways, and also there is Amazon VPC user guide. Also there are lot of documentations here. If you have any doubt, you can go to these documentations and you can search for them. AWS database, compute, web server, and also PM2 documents we have also added here. So you can go through them and get some knowledge. And also we have added error handling part as well. If you get any error, you can go through here and check if the error is added in this error handling. So if the error is not added in here, you can ask that from one of your commenters, or you can add it in your group in Discord. So if others have the same issue, they can answer you, or you can debug together. Okay. Here you can see the app architecture. I think this has explained yesterday. Okay. Is there anything I need to explain? Okay. Okay. If you need to connect to a private EC2 instance, you can also use the method of AWS System Manager or Session Manager. This is one method as well. If you have time, you can search for it and go through it. So it's not mandatory. I was just mentioning it. I think Joy has explained this first method using a jump host. And in Azure, you also have Bastion host for this method. So you can try this method too. AWS Systems or Session Manager. If you have any doubt regarding that, you can ask from us. I'm not going to explain because it's not mandatory. I have added the steps. Okay. I have added the step here as well. For now, you can use this method 1. And for later assignments, if you need, you can use this one as well. You can try it. Okay. Engineers config have done. This one is done. High availability is done. Okay. May I know, did Joy explain yesterday the difference between multi-AC and read replica?
Come again, Angela. We didn't hear, we didn't hear you.
Hello. Sorry, I couldn't properly hear you.
I did not hear your question. You asked the question.
Oh, okay. What I was asking is, did Joy explain yesterday about the difference between read replica and what do you call that? RDS high availability. Someone can remember.
I don't think so actually. Read replica versus RDS, is it? I don't think so.
Okay, give me 1 minute. Multi-AC. The difference between read replica and multi-AC.
You mean multi-available zone? I know, I'm not sure.
Okay, I will go through it again.
Maybe I was thinking actually. To be honest, I don't know how many people are going through it actually, but I was just thinking from my side actually.
Uh,
So I think the assignment 5 and assignment 6 looks to be more or less same, but only thing we are going with the extra subnets and extra availability zone, is it? That's the main difference, or what is the other difference? Because I see like I was on now doing assignment number 5, and now whatever you explain assignment number 6 actually. So more or less it looks to be we are creating the same, but we are creating some extra subnets.
uh, in assignment 5, we are creating 2T application, and here we
Yes.
are creating 3T application. That is one difference.
Okay. Basically, there we got Nginx, which acting as a web server, and we have the database, and I don't know. And here, when you say three-tier application, we have the web, app, and DB. Is it? There only the web and DB. Is it?
Yeah, yeah.
Okay. Okay.
You mean assignment 5, right?
Yeah, yeah, yeah.
Okay, I think I
Because
will.
I see the steps are
Okay, go
more or
ahead.
less. Sorry, I see the steps are more or less looks to be a bit same actually. Only thing in between a bit of more added actually. I was just thinking what is the difference actually. Yeah, but now I got it. Okay.
Okay. If you start doing this 3T application, you will see the difference because
Yeah,
in most cohort, this is the application most students are struggling.
first I see that looks of it actually.
Yeah.
The only problem is we have many concepts actually, which we can, I mean, like, we can do the assignments by following the document, but the concepts, I think, getting it's not easy actually, because I have many questions I have still going on in my mind actually. But anyway, let's see.
So going forward, everything will be easy for you. So if you have any question, you can add them in the groups so we can view them and answer for them. Because
Yeah, actually, the only problem is I don't want to trouble you guys because I was doing on myself, so that was I was taking some time. So simple questions is like we started IP addresses for VPC 10.0.0.1 1 by 16, and we started
Mhm.
the subnets by 24 1.0 dot by 24. Okay, like half of the partition of 16, like we started with 24, but that kind of mechanism to start with, how we will be able to know. Okay, I know that. Okay, we're just following it. Okay, this is a sub part of the VPC, so we need to start by 24. But how we decide that we need to start with 1.0 or 2.0, and how much should we reserve, you know, like, if I'm starting the second subnet, should I start with 2.0 or 3.0 or 4.0? How much I need to reserve, you know? So those kind of basics, I'm like, just trying to understand. If I go deep, you know, then everything is like, I feel like, but if I go in very light on the high level, just follow what is there and do it, then it will be light, So I don't know how the others are doing it.
Actually, that part is coming from networking. So if you're trying to go deep, it's better.
Hmm.
But there is something like, can I explain it? Those decisions are mostly taken by network engineers, but we also need to understand those things.
Hmm. Exactly. Just on the high level, not, yeah. And also I
Yeah,
feel actually, yeah, the other things are there. So that is a just example. So maybe I think the other things, but I'm still like
okay, if I
going
find
slowly.
any references, I will give it to you. I will
Okay,
check
no worries.
it.
Thanks.
So you can go
Yeah,
through them.
thanks, Anjana. Even I'm checking it online actually with the AI and everything. So it's explaining it. That's why, because this kind of questions I can't keep asking on Discord, because I can ask actually, but we can make use of AI. So that I want to say it, what I want to say it is taking some time actually. It is not that like previous assignment we can just do it at a full blown.
Actually, I have done networking previously, so there are some things, but understanding them is better. But if you are trying to go deep, can I explain it? So as I understand, you are doing better.
Hmm. I got you. What you are saying is actually, if we start going deeper and deeper, I think we revolve around there actually. So we
Yeah,
need to
there are a lot of
what we
things to explore if we are going
explore
deep.
exactly. Yeah, exactly. I got you. What you're saying. Yeah.
Yeah.
I think we need to take what we want and then we need to move on rather than we
Yeah.
going around it. Yeah, exactly.
And if we have extra time, we can go deeper.
Deeper, exactly. Yeah. There, this two classes, I think this class especially is a very, very important topics actually as a DevOps engineer, I felt actually because these are, how to build infra and everything. Of course, using Terraform, Ansible, we can automate all these things, but understanding these
Yeah.
concepts is much important, you know.
Yeah. That's why actually in Agentic AI, also we have not go deep in Terraform. Instead of we
Mm.
try to add new assignments and we try to explain the concept first. So instead of struggling with Terraform, you can understand the concept first and apply them to these going forward these lectures and
Yeah.
assignments.
Yeah.
And here also this assignment we can simply tell you can add some user data script and you can do it. So instead of that, we selected the path to do it manually. So you can learn, you can struggle, you can troubleshoot, you can debug, and we think that's the best way. So when it is coming to Terraform and going forward, it will be very easy for you.
Only thing, and the user data script that I don't know, like, okay, so whatever I written user data script and what you are saying it might be same or it might be more extra, we can do it. So what I did is whatever we're supposed to install within EC2 instance, that can be done in a data script, like whatever supposed to be installed within the EC2, whatever the things that we need. As soon as the it span up the EC2, it will bring up all the things are ready for you. You just need
Yeah.
to get it. But I was just thinking, apart from that, we can still go further and build this VPC subnets as well using the data scripts. We can do it, or it is a part of again uh, something else.
No, you mean creating VPCs and other things.
Yeah, exactly. Yeah. We are just now manually doing it, right? Manually adding the IPs, manually creating it, But when I launch the EC2, when I launch it EC2 instance, yes, we write the script. So whatever inside the EC2, whatever you need, that script will take care of that actually. But if we have any kind of a data script, or it's only Terraform will take care of like creating the VPCs or these external creation of VPCs, networking, everything, subnets and everything.
Can you remember in assignment 5 we used, it's not actually a script. What do you
Mm.
call that?
Yeah, I say it as you run bash shell script, is it? You're saying about?
No, not share script. Give me 1
Mm.
minute. I